Hi everyone. Sorry I can't be with you today for the review, but I thought I would go through some of the homework from last night from section 1.5 on geometric sequences, infinite geometric sequences. So a couple that I wanted to focus on maybe were some of the more difficult ones. Number 6 is an interesting one because you had to rearrange to find the T1. So let's take a look at a few of these and then I'll talk about the review. So number 6, they give you the givens that we have are the sum, the infinite sum is 81, the R is 2/3. They're asking us to solve for T1. So we need to use the formula T1 divided by 1 minus R, and then replace what we know. We don't know T1, we know R, which is 2/3. So then you're left with 81 is equal to T1 over 1 minus 2/3 is 1/3. In order to solve for T1 then, just multiply both sides by 1/3. Multiply this by 1/3. And you'll get your T1, which is 27. That was one that was a bit trickier. The other ones I want to take a look at were number 9 and 10. So it tells us the infinite series is given by 1 plus 3x plus 9x squared and so on. So 1, 3x, 9x squared. So again, we're going to have to solve for what is the value of x? And it tells us it has a sum of 4. So the infinite sum is 4. And this time we know our T1, which is 1. We don't know R though. So we need to solve for R using the same formula as before. T1 over 1 minus R. Substitute what you know. T1 is 1 and 1 minus R. Well, since we don't know R, what we would do is we would move this whole piece over for right now. So multiply both sides by 1 minus R. So you're left with now the 1 minus R times 4 equals 1. Move the 4 over. Now you're left with 1 minus R equals 1/4. In order to solve for R, move this 1/4 over and bring the R to the other side. You now have 1 minus 1/4 equals R, 3/4 equals R. Okay? Then, number 10 is very similar to it. It says the sum of an infinite series is twice its first term. Determine the value of the common ratio. The sum is twice the first term. Well, we don't know the first term either. So since we don't know it, we'll call it x, and the sum is twice that amount. And we need to solve for R. So again, use the formula and substitute in what you know. For right now, we don't know much. So infinite sum is 2x. T1 is x. We don't know R. Same as the last problem. Move that whole chunk over to the other side. So you have 1 minus R times 2x equals x. Divide both sides by 2x. Now we're done. You'll have 1 minus R equals, those x's will cancel and just be left with 1/2. And again, that means that 1 minus 1/2, you move the 1/2 to the side and the R over there. So you have 1/2 equals R. Okay? So there are some examples from homework that may have caused a little bit of trouble. I think the rest of them look fairly good. The only other one might be 15, the ball dropping one. So a ball is dropped from a height of 16 meters. The ball rebounds to 1/2 of its previous height each time. If the ball keeps bouncing, that means going on forever. What is the total distance to travel? Now remember, total distance to travel is made up of upward and downward bounces. So T1 is 16, and our ratio is 1/2. So we solve this just as if it's a normal infinite series. First off, 16 divided by 1 minus 1/2. So you get an infinite sum of 32. However, we can't just end there because that's just calculating the heights of the ball. Remember, this is made up of upward and downward bounces. Upward and downward. So you're going, and it starts up here at 16. So 16, but then it's going up and down. 8, 8, 4, 4, and so on. So we have to double this. We double that to get 64. Remember, this one only did a downward bounce, so then we have to subtract off 16, and that leaves us with 48. Okay, so that's a little bit of the homework. Now let's talk about the review for the test on Wednesday. So, again, will be made up of a combination of multiple choice and short answer, and also a few problems. So what did we cover in this section? Well, 1.1 and 1.2 were arithmetic. Sequences and series. A few things to remember. You can use common sense. You don't have to use a formula, does it say? So if you're stuck, try to use common sense. Make a list, make a pattern, find a pattern, and then keep going. Try to skip count. Other things to be on the lookout is that wonky n. Wonky n. It's usually found in years or the bouncing ball kind of questions. So just be on the lookout for those. Then 1.3 and 1.4 are geometric. And again, there's the wonky n, and this time we encountered the wonky r as well. Wonky r. And that can be found usually with a growth rate. So other similar ones might be like the genes question or medicine, where you find some of those. You also may need to use to rearrange the formula to solve different parts. Rearrange the formula. And also, what was I thinking? Rearrange the formula or use a system to solve. Those all could be questions on the test. System. Okay, and then 1.5, which we just talked a little bit about, was infinite geometric. So remember, with infinite geometric, the r has to be between -1 and 1. So it has to be bigger than -1, or r has to be less than 1 in order for it to exist. Okay? called convergent series. If it doesn't, it's divergent, and it goes on and on. You can't calculate the infinite sum. This one, it means it approaches a sum. Doesn't mean it's exact, but it approaches it. We'll be learning more about that in calculus next year. We'll talk about limits. Okay, so where are you going to go to do some review? Review, page 66 to 68. Numbers 1 to 3. And you could do 5 to 11. 12 ABC. And if you do a big fraction one. 13. 17. And then 19 to 22. Pretty good. Okay? So hopefully that'll be okay for tomorrow. I'm hoping to be back on Wednesday for your test. Talk to you soon. Bye.